started. Recording has stopped.
Oops. It says the recording stopped, but it looks like it's still going, so we're going to keep going with it. So we're looking at micrometers today. We looked at the calipers yesterday. Now, the micrometers have two main parts, the barrel and the thimble. Realistically, I'm sure you guys know, micrometer, kind of a C-clamp looking thing. Looks something like this. There's a jaw over here that things rest up against, and then this piece here slides in and out as you turn the thimble here on that axis. So the barrel is connected to the jaws of that micrometer. That main scale stays stationary. And the thimble turns, and as the thimble turns, it travels up and down the barrel to allow us to read that dimension. This is an inch micrometer. Micrometers typically have no more than 1 inch of travel. The reason being is they are very, very precisely threaded. A thread is 25 thousandths of an inch. So as you're turning this thing, sorry, not 25 thousandths, 40 thousandths of an inch, I should say. So it's a very, very precise threading. So you have to turn this thing a lot of times to get it to go up and down the axis. Literally, you'd have to turn it 100 times to get it to go 1/10 of an inch the way she's threaded. Because of that, excuse me, if it was more than 1 inch of travel here, it would take forever to move that jaw in and out. So micrometers have 1 inch of travel. Now this would be a 0 to 1 inch micrometer, which means it will close all the way tight down to nothing and then open back up to 1 inch. But they do make 1 to 2 inch micrometers. What those look like is the closest the jaw will close. When it's all the way closed, there's still a 1 inch gap here. That's as tight as it will go. And then it opens all the way up to 2 inches. They make 2 to 3 inch micrometers. Very similar, when that jaw is as far closed as it'll go, there's a 2 inch gap there, and then it opens all the way up to 3 inches. I've seen them all the way up to a 7 to 8 inch micrometer. I've had students tell me they've seen larger ones than that. But that's how they work, is they have that up to 1 inch of travel on a micrometer. So let's just take a look at reading some of these things. So our main scale on the barrel here reads not inches, but tenths of inches. Remember, we said it only goes up to 1 inch. So these are tenths. So this is 2/10 of an inch. That's 0.2 inches. These marks in between are quarter marks, like we saw on the vernier caliper yesterday. This is 0.1, this is 0.125, 0.150, 0.175, 0.2. 0.225. So we have to put that 25 in there because we're past the first quarter mark, past the 2/10. And then we read what's lined up on the thimble. The thimble is read where it lines up with the axis of the barrel, which of course is the 15. That's 15 thousandths added on to that. So that's 0.240 inches. So this one, as we look at it, how many tenths are there a reading on the barrel?
4/10 of an inch.
4/10 of an inch. Have we passed that first quarter mark?
Just barely.
Yeah, actually we're actually dead on it. Because the 0 of the thimble is lining up with the axis. That tells us we are exactly on a quarter mark. That measurement is exactly 0.425 inches. How about this one here? How many tenths? Well, have we made it to the 8? That's the big question here. And how would we know?
Zero's lined right up.
Yep, so the 0 on the thimble, once again, is lined up perfectly with the axis of the barrel, which is telling us we are exactly on one of those markings on the barrel. Well, we are definitely past the 0.775. So that means we are exactly lined up with the 0.8. So a little bit of review. Do we need those zeros there? Mathematically, we do not. But remember, measurements have their own rules, those significant digits and such. So yes, we do need those zeros there, because if somebody else is reading this measurement, they need to know that it was measured to the thousandth of an inch. Happened to come out closest to 800 thousandths. So this one here, what do we read off of the barrel? Tenths and quarters.
Roughly 975.
So 0.975, good. What do we read off the thimble?
5,000.
5 thousandths, very good. So we add that up, that is 0.980 inches. So here, what are we reading off the barrel?
6, 5.
0.5.
Oh,
How
yeah.
do we make it to the 6?
Yeah,
That's a
yeah.
good question.
Sorry. My mistake, Chase.
No, we're not quite back to 0 here yet, so we have not quite made it to the 6. That's 0.5, 25, 50, 75. Now, what does the thimble read?
24.
24, so 24 thousandths. That is 0.599 inches. So here, well, just read the whole thing for me.
0.6.
What was that?
26.
0.626, good. I know a lot of people that when they read these actually have to have a scrap piece of paper to write them down, just because of the combining with the quarters on the barrel and combining with the thimble. It takes them a little bit. If you're going to use them a lot, it pays to get good at them to just read them off rather than having to jot them down and add the numbers. But it is certainly understandable if you have to do that. So what's this one read?
.434, Todd?
Okay, good. This is 0.4. We're past the quarter mark, so that's 0.425. Then this is the 9 that's lining up, so that's 9 thousandths. So that does add up to 0.43, and I wrote it down wrong, 434 inches. Now here I'm going to give you a little bit of a curveball. Let's say that up on the jaw of this one, it's labeled as 2 to 3 inch. So that means our measurement starts out at 2 inches, 2 point, and then what's it say on the barrel there?
Yeah.
7, 2.7.
47.
Okay, perfect. 2.747. Because this is 725. Then this is another 22 thousandths. So that is 2.747, and of course that's in inches. They make what's called an inside micrometer or a depth micrometer. The depth micrometer actually only has a 1/2 inch of travel on the thimble going up and down the barrel. They only make one of these depth micrometers. They don't make, multiple. So in order to measure anything deeper than a 1/2 inch, they use these extensions. So this is a 3 to 4 inch extension, which is telling us that whatever we're measuring with this starts out at 3 whole inches. So then we go to the barrel here, and that is, of course, 0.225. And then on the thimble, it's
Another 20,000.
another 20,000. So this is 3.245 inches is what that's reading. Now this one looks very similar. It has the 3 to 4 inch extension. But as I flip back and forth, tell me, what do you see that's different between those? What's that?
Out farther? Yeah.
There's an extra little piece there. You can see that piece is not on this one. That is a 1/2 inch extension. What that is, remember we said that the barrel, the thimble going up the barrel only has a 1/2 inch of travel. So to get that extra 1/2 inch, we have that extension. So this one had the 3 to 4 inch extension, which was telling us we start out at 3 whole inches. This one has the 3 to 4 extension plus the 1/2 inch extension, which is telling us we start out at 3.5 inches. Then on the barrel, we have what?
0.325.
837. 3.8.
Okay, perfect. You got the 0.325, and then we got the 12. So you're absolutely right, Hannah. That is 3.837. So give this one a shot. I'll give you a couple seconds, and I'll have you yell it out to me. What's that one measure?
2.374.
Perfect. 2.374 inches. This is saying 2 whole inches. This is saying 0.350. And this is 24. That adds up to 2.374. Now you can always tell an inch micrometer. There's 2 big tells. One is these are labeled in ones, 1, 2, 3, 4. The other is the dial goes from 0 to 20. It technically goes from 0 to 24 on the thimble, and then 25 is back at 0 again. When we switch over to the metric micrometer, the millimeter micrometer, you can see that barrel is now labeled in 5s, not 1s. And the thimble goes from 0 to 45, technically 0 to 49. And then at 50, it wraps down back to 0 again. So on the barrel of this is 15 millimeters. That's 16, 17, 18, 19, 20. You'll notice we do have half marks in between. So this is 15, 15 and a half, 16, 16 and a half, 17, and on up the line. So this is 20. Have we passed the 21 mark?
Yes.
Yes, we've just passed 0, so we have passed the 21 mark. That is 21 whole millimeters. What does the thimble read?
5.
It reads 5. And on the millimeter micrometer, that is in hundredths of a millimeter, so that is 0.05 millimeters. So 21.05 is what that reads. So here, on the barrel, 15, 16, 17, 18 and a half. So we start out at 18.5. Now you might say, well, geez, we're almost back to zero, but that line is clearly outside of our thimble. So what that is saying is we will be almost to the 19. What lines up then on the thimble is the 45. So we add the 45 hundredths to that. That is 18.95 millimeters. So here, what are we reading off the barrel? Eight. Well, it looks like 8.5, but we're getting close to the 9.
9.0.
When we look at the thimble exactly, we see that the 0 lines up perfectly. You're absolutely correct, Peter. That is exactly 9.00 millimeters. Again, mathematically, those zeros aren't important, but since we're dealing with a measurement, we need them there so that we know that it was measured to the 100th of a millimeter. So what's this one read?
Standard land. 0.8.
0.8 what?
98.
0.898. Very good. That is in inches, so everything is asked after the decimal point again. What's this one read? Point 338.
Yeah. 38.
This is 0.325 plus another 13 is 0.338. Very good. How about this one?
$13.03.
Careful.
14.0.
14. Perfect. There you go. 14.03.
Millimeters, right?
That is millimeters. You are correct. I wrote inches. Good catch. That is millimeters. How about this one?
$12.85 millimeter.
You got the right idea. Not 12 though.
Oh, 17. My
There
bad.
you go. 17.85. I'm guessing you guys have worked a lot more in the shop with the inches rather than the millimeters.
Yep.
Yeah.
And Parker has me at a disadvantage because we use mostly digital calipers and a good chunk of our micrometers.
Yep. And digital is not bad. Cheap digital is bad. I have students that come in all the time and say, I'm just gonna use a digital. I don't need to know how to read a caliper or micrometer, which is fine, but be prepared to spend at least $300-400.
Ours are,
What's that?
yeah, I think ours are through Mitutoyo. I know they spend a lot of money to make sure that they're quality and they do have them recalibrated once a year.
Yep. And the biggest thing with digital is they need to be, they can't stand wide temperature variations. That'll throw them off calibration really quickly. I have students all the time that come and say, oh, I got a digital caliper for $80. Well, that's great, but it's not going to be worth a crap. You can actually get a decent dial caliper for around $30 or $40, just because they're cheap and they're easy to calibrate. You can get a relatively reliable dial caliper for under $50. Okay, so what we want to look at here is we're going to look at some varying meters, and I'm just going to skip around because some of these are not terribly important to you guys anymore. But a multiple scale meter like this is worth taking a peek at. I realize it's probably pretty small on your screen up there. But here we have one scale, but 3 sets of numbers. This switch is saying we've got the 18, the 16, or the 24 volt setting. Obviously, this would be the 8 setting, the 16 setting, and the 24 setting. This is on the 16 setting right now, which means we're using this middle set of numbers. So this line is labeled 12 on that middle set, and this line is labeled 13, and I wrote those where you can't see them. Let's put them up here. This is 12, and this is 13. And that's usually where we start, is at the nearest labeled markings. Now, between those two labeled markings, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces, 10 gaps. That is a 1 volt space split up to 10 gaps. That's a 0.1 volt per gap, or a tenth of a volt per gap. So this is 12.1, 0.2, 0.3, 0.4, 0.5, 0.6. That's 12.6 volts. Is that reading? Here's something you might see as far as a power meter. Ohm meters you won't use anymore. Use digital multimeters for ohms now. But you could see this is what they call a logarithmic scale. You can see the spacing changes as we go up the scale. This meter actually moves backwards. This distance is only 1 ohm here. Up here, that same distance is more than 5 ohms. So the scale changes. These, you can't just look at it and figure out what each division reads. You actually have to look at exactly where the needle is and look at between the needle marks. The needle is pointing at this line. There's a 7 on one side of it and a 10 on the other. So we know it's between 7 and 10. And you almost have to just count it up. 7, 8, 9, 10, so that has to be the 8. And if you don't land on the other number, you got to recount using a different spacing. The biggest thing is to be able to look at a meter and figure out what the scale is. And again, here we have 2 different scales, so we have to know which one to read. Over here, do we read the top scale or the bottom scale? Well, we come down below here, and that is set on low, which means we read this lower scale, the smaller scale. That is at 250. Let's get back to these multiple numbered scales. This one's set on the 8, so that means we're using the smallest set of numbers. So this line here is 7. This line over here is 6. So that's a 1 volt gap from 6 to 7. If I count those spaces in between there are 20 spaces. So 1 volt divided by 20 is 0.05 volts per space. So this is 7 volts. This would be 7.05 volts to get to there. This one's set up on the 24 volt setting, which means we're going to use the bottom set of numbers. So this is 22 and this is 24. That's 2 volts from one to the other. And there are 10 spacings if I count them out. So 2 volts divided by 10 means each of those spacings is 0.2 volts. So this is 22.2, 22.4, 22.6. So the point I'm trying to get across there is you have to be very careful to figure out what the spacings are, what the spacings stand for, and then use that to read the meter. Okay, so what I have here is this is actually a surface gauge, depth gauge, however you want. It can go in either direction. You can see it's labeled positive or negative up here. So one of the first pieces of information I have to give you is which direction the needle has moved from the starting point. The needle will start up here at 0 and move from there. So this little arrow is telling us that the needle has moved in the positive direction. So this is a positive reading. Now this is a millimeter gauge. So this down here is telling us how many complete revolutions that needle has made. It's between 0 and 1, which means it's made 0 complete revolutions. So 1 revolution is a full millimeter, so that is 0 full millimeters. And then we read the dial here, which is at 17. So that is a positive 0.17 millimeters that has moved from its starting location, from its 0 location. This type of gauge, by the way, is used to measure surface variations for quality control. So for this one, it starts out going in the negative direction. So we know this is a negative reading. Down here on the small dial, we're between 2 and 3, which tells us we have gone 2 complete revolutions. Now, this is where it gets tricky to read this one. You notice that in each direction it goes 10, 20, 30, 40, 10, 20, 30, 40. Well, we have to, before we read the dial, we have to make sure we know which direction we're heading. We're going this way in the negative direction. So it's 10, 20, 30, 40, 50. This is actually 60, 70, 80, 90. So this is at 81. So it is negative 2.81 millimeters. So that is varied from its starting point by a negative 2.81 millimeters. This one here, once again, is negative. Between 0 and 1, so that's 0 whole millimeters. 29. Yep, question? Nope. All right. So I'm going to have you try to read this one for me. First of all, positive or negative?
Positive.
It is positive. Whole millimeters.
1 mil.
1, because it's between the 1 and the 2. Yep. And then what's the dial read?
24.
50, 60, 74. You are correct. So positive 1.74 millimeters. Now you'll notice a change here. 2 big changes. It doesn't say 0.01 millimeters anymore. It says 0.001 inches. And this dial down here now has decimal points in front of every number. So this is in the positive direction. This is between 0.1 and 0.2. So this is a positive 0.1. Then the dial is on 10. So that 10 is our 10,000ths. So that's our hundredths and thousandths digit. So that's 0.110 inches. This one's negative. This is between 0.8 and 0.9. You can see we're not quite back to 0. We're going this way. We're not quite back to 0, so we're not to the 0.9 yet. So that's 0.8. And 50, 60, 78. So negative 0.878 inches. That's quite a ways from the starting position there. So this one here, positive or negative?
Positive.
Positive. Tenths of an inch?
0.4.
0.4. And this is 37. Good. So positive 0.437 inches. We're at that time. Let's do 2 more here. Go ahead and read this one. I'll ask you for your answer in about 15 seconds here. So what's that one read?
0.44. Negative 0.44.
Careful.
Oh, 54.
56, yes. It is negative. It is 0.0. But remember, we're going this way, so that's 56. Read this one. What's it say?
Negative 0.258.
Careful.
Oh, no. Crap.
negative 2.58. So like I said, that is the biggest issue that most people have. Calipers, micrometers, other gauges, is going back and forth from inch to millimeter, is getting the decimal in the wrong spot. So I'm actually kind of glad you did that, because that is the biggest struggle that people have with these, is getting that decimal point in the correct spot. Okay, so in your big book, you have several pages on micrometers. Page 346, exercise 10.3. Page 353, exercise 10-7. Page 355, exercise 10-8. Page 363, exercise 11-1. Page 365, exercise 11-2. 367, exercise 11-3. And finally, page 369, exercise 11-4. So for each of those, make sure you can read each of those different styles. There are a couple of vernier calipers thrown in there, or vernier micrometers thrown in there. The vernier micrometer just has the extra level of precision. I won't make you read a vernier micrometer for your quiz coming up tomorrow, but it sounds like you guys have done a pretty good job with these in the shop, so you guys should be a pretty easy quiz for you tomorrow. Do you guys have any questions?
Are they all odds?
Yeah, you can just do the odds. Just do enough of them so that you're comfortable with them.